All right. Hi, guys. Welcome to Science. Hope everyone had a good spring break. If that's when you guys took your spring break or not, hopefully it was good. Hopefully last week was good, whatever you did. I have loved seeing your screenshots come in. They've been so fun to look at and to just make sure that we're all on the same page. It's been so great. And how creative some of you were with those thermoses. Those were super fun to make, right? Like, did you guys have fun making those? They were really fun to see how creative you guys got and how it worked for you. So thanks so much for doing it and for sending them in. Hopefully these kind of projects at home and experiments at home make science like this more fun. So we're going to jump into this today. Hopefully you have your paper and pencil already, and let's do this. All right, first off, 2 things that you learned from our last week's lesson. And I already gave you a hint because I said I liked all your thermoses. So 2 things. Go ahead and write whatever down that you remember or that you learned new. And gotta love these recordings live, how we are doing it. Anyway, take a minute, you can pause me, or if you're already done, perfect, I'm just gonna keep going on. So let's jump in with today's lesson, and this should be a good review for most of you, because it's just something that we touch base on in every year. So we're gonna jump into the water cycle. So I want you guys to write down on that piece of paper that your parents are gonna send me a screenshot of when we're all done with this lesson, but I want you to write down anything and everything that you know about the water cycle. It could be words, it could be sentences, but go ahead and write down some things that you know about the water cycle. That is what we are jumping into today. So go ahead and either pause me, or if you're already done, then we'll just keep zooming through this. So a little bit about how we're going to work today is I've got a fun experiment that we would normally kind of do in class, and I'd have helpers come and help me and stuff, but I am going to have my daughter do it step by step as I kind of walk her through it so that you guys can do this at home. And most of this stuff I tried to kind of recreate so you could usually have this kind of stuff on hand at home. So if you don't get creative with it, once you see it done, you'll understand. So anyway, we are going to go ahead and do that. But very first, let's just get a good review of a video telling us about the water cycle. So let me see if I can share this the right way. Bear with me for a second. Computer sound on. Here we go. Now that's the right video. Start it. Okay. Nope, right there, right here. Okay. All right, guys. I will become a pro eventually. I promise.
All the water on Earth today, every drop, is all the water there has ever been on the planet. Fresh water is actually millions of years old. The same water flowing in a continuous loop, falling as rain and snow from clouds to the Earth's surface, running in rivers, pooling in ponds, flowing from faucets, irrigating crops, traveling through plants, generating power, eventually evaporating into the air and condensing into clouds again.
Why is there life on Earth? And the reason there's life on Earth is because Earth has this perfect water cycle.
The water cycle. So simple, even small children understand the basics. Yet so complex, the most advanced Earth scientists, hydrologists, geologists, and biogeochemists are studying every part and process.
The water cycle is fascinating. It's something that's around us all the time, and yet we don't really understand it.
How to summarize what is known about the water cycle? With 2 words, flows and stores. The water cycle is a series of flows of water between various water stores or storages. Clouds in the atmosphere.
There's always a little bit of water in the atmosphere. We talk about relative humidity. It's a humid day, it's a dry day. Either way, there's water, sometimes a little, sometimes a lot.
There's a lot of water in the ocean, 70% of all the water on Earth. In the ice sheets and glaciers, 2/3 of all the fresh water on Earth. In the snowpacks atop mountains like the Sierra Nevada. In the Great Lakes. in rivers and streams, in reservoirs and watersheds, in wetlands, in the soil, in and on plants and trees rooted in the soil, and beneath the soil, in water tables and underground aquifers like the Ogallala High Plains, which runs underneath parts of 8 states from South Dakota to Texas. All this storage is temporary. Water in all its forms is always in flux and always moving. And there is a name for every kind of movement in the water cycle, starting with precipitation.
Precipitation is the process of water falling onto the surface of the earth. You can have precipitation in many forms: rain, snow, hail.
Rain is falling water in liquid form. Snow, ice, hail, and sleet are falling water in solid or frozen form. Fog and mist, falling water in gas or vapor form. Precipitation that falls directly onto the oceans becomes part of surface ocean and can be churned by wave and wind action into ocean currents. Rain and snow that falls directly on rivers and streams becomes one part of stream flow. Rain that falls onto land takes a different path to the river, as does the snow and ice that falls and collects on mountaintops when temperatures warm.
When snow melts, some of it runs through the snowpack and goes into small streams, tributaries that feed into large rivers.
What about that precipitation that falls on and over land? Some is intercepted by vegetation, plants, and trees.
Like you might imagine someone in the game of football intercepting a pass. These are raindrops trying to come to the ground, and the leaves on the tree intercept them before they hit the ground.
And the precipitation that does hit the ground, it can run off if the ground is hardscaped, covered with asphalt or concrete, or if the soil is too wet or saturated to absorb more water, like an over-soaked sponge. Otherwise, precipitation infiltrates the soil surface, percolates into the ground.
Think of it as the water percolating through your coffee grounds in the morning. Gravity continues to pull it downward so it will move through.
Through the topsoil, into spaces between soil and rock particles, down to bedrock and further into fractures, into deep underground aquifers. Even groundwater here is moving sideways or laterally, discharging toward a river, lake, or the sea. Generally, the deeper the flow, the slower the flow.
Some of that fractured water might take a very long time, thousands to millions of years to get out.
And how does water get back out into the atmosphere? It evaporates, is turned from a liquid into a gas or vapor by the heat of the sun.
If you put a bit of water into a bowl and you set it outside on a sunny day, it's going to disappear. It's still water, it's just in the form of a gas rather than the form of liquid.
Water evaporates from every wet surface, even from wet air. Some rain and snow evaporates into the air while falling. Water evaporates through our respiration and perspiration, and from plants through transpiration. Trans means through or across. Plant roots draw up groundwater.
And plants pull that water up through their stems into their leaves and then release it back out through evapotranspiration.
Evapotranspiration, a spelling bee-worthy term for evaporation from soil and water surfaces, plus transpiration from plants. Evaporated water molecules are tiny enough to flow into the air, mix with smoke and dirt particles in the atmosphere, cool, condense into visible masses of water vapor, clouds. Winds move clouds into colder air, water droplets collide and merge, grow bigger and heavier, until they are so heavy they fall again, as rain or snow, sleet or hail. Precipitation, collection, runoff, interception, infiltration, percolation, discharge, transpiration, evaporation, condensation. The water cycle.
All right, hopefully you guys enjoyed that awesome review of the water cycle. Let me try and get out of this. Okay, there we go. All right, so let's do this experiment since we just had that review. And then after the experiment, I have some questions I want to ask you guys, and you're going to answer them on your paper. So I am going to carry this out to our experiment area. Welcome to my classroom, my home. All right. Okay. Hi, guys. Why is there not a screen showing?
Just start video.
Nope, it's recording. What is going on? Okay. It takes children. Seriously, it takes children. All right. We're going to try this. This might be a little tricky. I'm going to have to like maybe hold this up. All right. So everyone start with your supplies. Let's see. We need, I have my water on, getting warm, but you need like a shoe-sized plastic container. You need, point to the gravel, some gravel, dirt. I just got some dirt out of my garden. We're going to use that. You need some rubber bands. And you need some kind of a jar or a lid. Then you need a bag of ice, which is in the freezer. You need some saran wrap, and then you need some kind of lamp, some kind of heat source. So this is our little lamp that we got. All right. I'm going to walk her step by step. So the very first thing I want you to do, Raleigh, is get a little bit of water in your container, and the water should be warm. We want it to be somewhat warm. All right, that's good enough. Okay, go ahead. Turn the water off. Okay, so I'm going to have her put in some food coloring so you can actually see the depth of the water in there. There we go. That works. Okay, stir that around if you can. So she's only got just a little bit of water. All right, now I'm going to have you take your land. Well, okay, so the baggie of dirt we're calling land. So hold that up, you can show them. So I just put it in a little Ziploc. I'm going to have her put it in one side of the water. And we want our water to be obviously not on the land. So if you guys can see, let me see if I can bring this. Is that going to work?
Sure.
So our water is not over our land. Okay. Okay. The next step, I want you to take the jar lid, and I want you to make sure it's the lid, that the lip is up, and go ahead and set it on top of your land inside there. Then I'm going to have you cover it in saran wrap, the whole thing. Cover the whole shoebox in saran wrap. And then you're going to take the giant elastic and you're going to seal it around the edges. Remember, you tear it on the bottom. And when you guys are doing this, if you can get all the wrinkles out and make it as tight as possible, it will help trap in the air. Because remember, we have warm water in there. So if you guys can already see, things are happening in that container. Hold it on that end. Okay, so she's got it pretty tight, and then to just double seal it, she's going to take a giant rubber band. And if you guys don't have a big enough rubber band, you can always tie rubber bands together to make it fit around. So make sure you go around all of the edges and make sure it's all sealed. Sorry, I got wiggly there for a minute. Okay, so make sure it's all sealed. Does that look all sealed to you?
Yes.
Okay, now I want you to get the ice out of the freezer. And I had just put some ice cubes in a baggie. So I've got some that's already ready to go. So crunch those up a little bit. You're gonna set them on the land side. So set them on that side, just on the plastic above the land, above that jar lid. Then you're gonna take your heat source. So we've got our lamp, and she's gonna hook it to, yes, we might have dress rehearsaled this a little bit. We had to see how this would work. So we have this kind of little cheap IKEA lamp, but I want you to put your heat source on the water, not on the ice cubes, so on the water. And if you put that directly, and it can be a hotter lamp, just be careful of how long you're leaving it on, you know, facing that plastic. But that is going to keep our water warm, and it's going to heat up our water. And I have questions for you now. All right, that is the experiment, and I will go back to the office and we'll resume this with questions. Thanks for your help, Miss Raleigh. All right, how do I pause? Okay, here we are, back to our classroom. Okay, all right, that was nice of her to help me out through that. So hopefully that experiment made sense. I'm always a visualer and I love how we get to do hands-on in our school. So hopefully you guys can do that at home and do that experiment and actually see it firsthand what happens, because it's really cool. And I'm not gonna say the words because that would just give it away. So if you do the experiment, go ahead and write down what starts happening, how long your heat source, what is a heat source? I want you to go ahead and write down how long your heat source stays on for and what starts to happen, what happens to the ice cubes, what happens inside the saran wrap, what happens to that lid. Why did we put that lid there? Answer that question for me. Why did we put the lid on top of our baggie of land? Why did we do that? Okay, I have a couple other questions too. So I'll go through these kind of slow so you guys can answer them, so you don't have to keep pausing me. But so we did our experiment. What is the energy source in our water cycle? What was the energy source in our experiment? So what is our energy source in the water cycle? All right, answer that one. In this experiment, if you haven't done it yet, what do you think is going to happen? What's going to happen to what, like I just asked you, why is that jar there? What's going to happen to that jar lid? What's going to happen to the ice? What's going to happen on the sides of our plastic container? Yeah, so what's going to happen? I want you guys to go ahead and write down what will happen. Let's see, another one. What would happen if we added a second light source or if we added a more powerful source? I'm not sure of that watt. It's just a little IKEA lamp. It's what we had. So what would happen if you added a second source or a more powerful source? So maybe experiment with that. Why don't you go ahead if you do experiment with that, if you try something different. I would love to know what you did. So be sure to tell me if you tried a different source or if you tried 2 sources of light. Okay, and then last one, what would happen if we didn't add a heat source to it? What would it do? What if it just sat in a closet? We did everything, but we never added that heat source to it. What would happen? Okay, answer all those for me. All right, I've got another fun project that I wanted you guys to do at home. It just as a reminder, a review to kind of have a visual of what we learned about the water cycle. So we have some words. Hopefully these aren't backwards. All right. So we have evaporation, condensation, precipitation, transpiration, collection, and runoff. So evaporation, condensation, precipitation, transpiration, collection, and runoff. Each of these words is unique and it's all part of our water cycle, right? So I want you guys to create on paper or a paper plate. I've seen them done like on a paper plate and it just is the whole circle of the water cycle, or a piece of paper, a poster if you want to get really big. I want you guys to create a water cycle at home with these words. So if you need to pause it, so you can go ahead and let me make sure I got all those in. So if you need to pause it to make sure you got all these words, go ahead and pause it. But I want you to make a creation of the water cycle using all of those words. I don't know, this is kind of hard to see. I had my daughter make it for me. So you've got precipitation, you've got the rain coming down, then you've got, I'm looking at it backwards, you've got the runoff, you've got the collection, you've got evaporation, you've got your trees that create transpiration. So, all right, I want you guys to create a fun water cycle. Be creative, be 3D, like this is a little bit 3D, or use whatever. Just be creative. And if you don't want to be creative, you just want to write it on paper, just normal piece of white paper, perfect. However you want to do it. I don't know, some kids are wanting a lot more to do and some aren't. So however you want to take it, just using those, how many words is that? 1, 2, 3, 4, 5, 6 words. And again, they are evaporation, condensation, precipitation, transpiration, which we didn't go over very much. So let me just remind you what transpiration is. It is the process of water moving from plant to atmosphere. So it is the oxygen and everything that the plant is holding. It takes all that moisture from it and releases it into the atmosphere. Totally my hand talker today, aren't I? Okay, and then we have collection, which is another good word for gather, and then runoff. So that would be, when I think of runoff, I think of, the mountains with the snow running off into larger pools of water. So make some kind of fun creation, or just keep it simple, however you want. Have your parents take a picture of it and send it to me of the water cycle. Okay, all right, easy peasy. Hope everyone's doing good, and until next week, we'll see you later. Have an awesome one, guys.